All right, so we're going to take a look at this example now. I've got negative 2y plus x is equal to negative 4, and 2x minus 4y is equal to negative 8. Now, if you're looking at this problem before you attack it, you notice that I have y and then x on the first equation, and then I have x and y on the second equation. So I need to reorder this first equation. Okay, we should have both of them in the order of x and y, not y and x. So I'm going to take this equation here, I'm going to rewrite it. Remember, a plus b is the same as b plus a. So I can rearrange that to be x minus 2y is equal to negative 4. No difference in that problem there. And then my second equation becomes 2x minus 4y is equal to negative 8. It's important that we have everything lined up. We notice our x's are in the first column, our y's are in the second column, and our constants are in the third column. That means when I enter my matrix, the matrix I'm going to enter is going to be 1, negative 2, and negative 4, 2, negative 4, and negative 8. It's a 2 by 3 matrix, so I won't have to change anything from my previous problem. So again, x, or second, x to the negative first, scroll over to edit, hit enter, and let's go ahead. It's 2 by 3, so I can enter a couple times and start entering in my matrix. 1, negative 2, negative 4, 2, negative 4, enter, and negative 8, enter. All right, when I get that done, I'm going to quit. So second mode to get to quit. Second, x to the power of negative 1. Go to math, scroll up, in my case, to go to ref, hit enter. Oops, I didn't hit ref. I hit ref, so occasionally goof that up. Again, hit the key to go back into matrix, math, scroll up a couple times, make sure you don't goof it up, hit enter. ref is now the correct thing that I'm going to look for. Go back in, select which matrix we're going to use, and there we go. Okay? Now we hit enter, and we find out our solution here is given by this. Well, now that's interesting. This would indicate, a response right here indicates an infinite number of solutions. So our goal here is to have infinite solutions. As I look at this with infinite solutions, start looking at this, take my first equation here. We're going to take our first equation here, x minus 2y is equal to negative 4. I'm going to multiply every term by 2. Well, what would I get? I would get 2x minus 4y is equal to negative 8. As we notice, these are the same equation. If they're the same equation, you have infinite solutions. Okay. And again, anytime you see this right here with 3 zeros, it's kind of almost like hitting a jackpot here. It's going to be infinite solutions. Now we're looking at a new type of matrix, and we see that there are now 1, 2, and 3 variables. So we're going to expand our matrix here. But in order to do this, we need to make sure we align everything such that I have ax plus by plus cz is equal to d. Okay? That is how we're going to have to do this now. And so our first column will be our x variables. Our second column will be our y variables. Our third column will be our z variables. And our fourth column will be our constant. So I'm going to have to do some manipulation to some of these equations. So my first one here, minus y minus 2x, minus y is equal to negative 2x minus 3z plus 6. I need to get the 2x and the negative 3z over to the left side of the equation. In order to do that, I'm going to add 2x to both sides. When I do that, I get 2x minus y is equal to minus 3z plus 6. I still need to move my z over. To do that, I'm going to add 3z to both sides. When I do that, I'm going to end up with 2x minus y, because I want to go x, y, and z, plus 3z, and that's equal to my constant 6. So that is one of my equations for my matrix. I'm going to have to manipulate another equation. So my x plus 2y is equal to z plus 8. Again, the z here on this side must be moved over to the left-hand side. To do that, I'm going to have to subtract z from both sides. When I get that, I get x plus 2y minus z is equal to 8. That would be my second equation in my matrix. Finally, I have to look at my third equation here. And let's take a quick look at this. All right, this is equal to 1. I have z here. I have 2y. But I'm missing one thing here. I'm missing an x term, which means this is 0x. So when I go ahead to create my matrix, I'm going to have 1, 2, and 3 3 rows, and 1, 2, 3, 4 columns. So 3 rows and 4 columns. They're going to consist of 2, -1, 3, and 6 for my first row. My second row will be 1, 2, -1, and 8. And my third row will be 0, 2, 1, and 1. And I will go ahead now and enter that in as my matrix. So again, I'm going to go to second x to the power of 1. I'm going to scroll over to edit. Hit enter. Now this time I'm going to have to change the dimensions of my matrix from a 2 by 3 to a 3 by 4. I'm going to go ahead and enter my data in. 2, enter. -1, enter. 3, enter. 6, enter. 1, enter. 2, enter. -1, enter. 8, enter. 0, enter. 2, enter. 1, enter. 1, enter. Okay? And now I've entered in my matrix. I'm going to go second mode to quit. Clear that real quick. I'm then going to go to second x to the power of -1 to get back into my matrix. Go over to math. Again, up to ref, I should say. Hit enter. It's going to ask me which matrix I want to use. I want to go back and use matrix A. Second, x to the power of -1 gets me into the matrix. It's a 3 by 4. I hit enter. I hit enter again. And I come out with this as my answer. Which means x is equal to 5. Y is equal to 1. And z is equal to -1. And my solution then would be 5, 1, negative 1. And if I were to graph this, I could graph this on a 3-dimensional axis. Okay? Where x and y would be your typical vertical and horizontal, and z would be, if you were to think about it in terms of a 2-dimensional object, 3 dimensions would be coming out of the screen or going into the screen in the case of the negative 1. All right? It's a little more complicated, but that happens when you're dealing with voltage, current, and resistance. So if you ever get up to the point where you're working with a lot of electrical circuits and those sort of things, you'll be working with a 3-variable, 3-equation system, which will give you a 3x4 matrix. All right? Again, we're going to practice it one more time. One thing we have to look for, again, everything must be written, in this case, as AX plus BY plus CZ is equal to D. Okay? When I look at my first equation, I notice I'm going to have to move 6Z over to the other side. I'm going to do that by subtracting 6Z from both sides of the equation. When I do that, I end up with 3x minus 3y minus 6z is equal to negative 3. Look at my second equation. I'm going to have to subtract 2y from both sides. I'm going to have to also subtract 4z from both sides. And what I get when I do that is I get 2x minus 2y minus 4z is equal to 10. All right, now dealing with the third equation, I'm going to need to move 2x over to the other side, as well as moving my negative 3y over. In order to do that, I'm going to subtract 2x from both sides. I'm going to add 3y to both sides. And this is going to cancel out those two terms. And it's going to leave me with negative 2x plus 3y plus z is equal to 7. That is a y there. Okay? Now, if I'm going to put my matrix together, I'm going to enter in the following: 3, negative 3, negative 6, and negative 3, 2, negative 2, negative 4, 10, negative 2, 3, 1, and 7. This will give me a 3x4 matrix. I'm going to go show you how to enter that in relatively quickly. So we'll go to second, x to the power of 1, go over to edit. You'll go in here, enter 3, enter, 4, enter, and then you'll enter in the rest of your matrix. And I will show you the completed matrix in a moment. This is the completed matrix. Now I'm going to go ahead and enter all that in and give us an answer. When we look at our final solution here, we notice that our last row here, where it should give us our z value, has 0, 0, 0, 1, and this means there is no solution to this matrix. It does not mean that a 3-variable, 3 equation system has no solution, but in this case, we have no solution.